Hi students, welcome to the chemistry class. This year we have to learn two parts of textbooks, part 1 and part 2. Part 1 has 4 chapters. The first chapter is periodic table and electronic configuration. Children, you know that periodic table is a comprehensive classification of elements, and the elements are arranged on the basis of atomic number. From this periodic table, we can analyze and predict the properties of an element. For example, if you know the atomic number of an element, you can determine its position and nature from the periodic table. For example, its group number, period number, and its properties. So I told you, the basis of the periodic function of elements is their atomic structure. Let's learn more about this periodic table. Students, you have learned about various atom models in 9th standard, haven't you? According to Bohr atom model, the electrons are arranged in various shells around the nucleus, and they are filled in the increasing order of energy. Remember, as the distance from the nucleus increases, the energy of electrons in the shells also increases. So what happened to the attractive force? The attractive force between the nucleus and electrons decreases. You know that electronic configuration of lithium is 2,1. Like this, can you write the configuration of sodium and argon? And tell me, how many electrons are present in the M shell of an argon? Right answer, 8. And what about the maximum number of electrons that can be accommodated in the M shell? Very good, it is 18. See the configuration of potassium. Even though the third shell has the capacity to accommodate 10 more electrons, why does the last electron of potassium go to fourth shell instead of occupying the third shell? This is due to the presence of subshells present in each energy level. You know that, according to Bohr atom model, the electrons revolve around the nucleus in a fixed path called orbits or shells, and these shells possess some energy. Inside these shells, there are sub-energy levels, which are called subshells. Subshells are sub-energy level in a shell. In these subshells, there are regions where there is a high probability of finding electrons, and these are known as orbitals. The maximum number of electrons accommodated in an orbital is 2. Remember, the maximum number of electrons accommodated in an orbital is 2. These subshells are named as S, P, D and F. S for sharp, P for principal, D for diffuse and F for fundamental. First one is S subshell. S subshell has only one orbital and it is spherical in shape. So the maximum number of electrons accommodated in the s orbital is 2. Next one is p subshell. It has 3 orbitals which are dumbbell in shape. The maximum number of electrons accommodated in p subshell is 6. Third one is d subshell. It has 5 orbitals and the maximum number of electrons is 10. And the last subshell is F subshell. It has 7 orbitals, so the maximum number of electrons accommodated in these orbitals are 14. See the table given in your textbook, the subshells and maximum number of electrons accommodated in each. Did you understand? Shall we go to the next concept? Okay. Now, each shell has its own subshells. That is, shell number 1 represents K shell. it has only one subshell, that is S subshell. Similarly, second shell, that is L shell, it has two subshells. What are they? S and P. The third one is M shell. So it has three subshells, S, P, D. If so, if N is the fourth shell, how many subshells will be there? Yes, 4 subshells. Did you understand? So students, what we learned today? We learned about relation between shells and subshells and the number of subshells present in each shell and the maximum number of electrons accommodated for S, P, D and F subshells.